On the second page of the notes for today, we're going to start out by practicing some of that vocab that we just practiced on the previous page. So the first thing it wants me to do is really look closely. It's almost kind of hard to see that this has the two little lines on either side. They're really tiny. Some students like to start by drawing in slightly bigger arrows above the lines so that they know that that says line AB. So the first thing it wants me to do on question 3 says give two other names for line AB. So line AB right here goes through points A and B, so it's this line that's right here on the paper. So one other way that I could name that is I could call it line BA. And then a second way that I could name it, and this one's different than what we've practiced so far. This little italicized H that's over here on where the arrow is on this line that doesn't have a point next to it, that's the other way that I could name it. So I could also call that same line, I could call it line H, and everybody would know that I was talking about that same line right there. Question B says, give another name for plane F. Plane F is this plane, this flat surface that's represented in the picture by sort of this rectangular slanted shape. So when I name plane F, I can call it by 3 points that are not on the same line. Well, there's only 2 points on a line, so that's fine. So I could call this plane ABE. And then they want me to come up with another way that I could name it. So instead of saying plane ABE, I already called it plane F, so I can't call it by plane F. I can take these 3 letters and I can switch them around. So I could also call it plane, there you go, plane BAE. And so that would be another way that I could name the same plane. So you're picking the 3 letters, you're just picking them in a different order. You can't use point C to name the plane because it's up above, and you can't use point D to name the plane because it's down below. The next thing they want me to do on question C says give another name for, and then notice that this symbol up here doesn't have any arrows on it. That means that it's a segment. So segment CD starts right up here, up above the plane. It goes down to B, and then this part of the segment goes below the plane, and it finishes at D. So C to D, the only other way that you could name it the same way would be from D to C, because line segments have length. You couldn't use the letter B because that would mean that it was shorter than the whole thing. Question D says name 3 rays that have endpoint B. So if B is the end point, that means that the 3 rays are starting right here. So I could do the ray that comes up, I could do the ray that comes over here to the left, and then I could do the ray that comes down. When I name these 3 rays, I'm going to draw my 3 one-way arrows. It says they have to start with endpoint B, which means the B has to go first on all of them. And then I'm going to name those 3 rays. So ray BC is one, ray BA is another, and ray BD would be the last one. Even though ray BA is coming this way and it looks like the A goes first, you have to put the B first when you name it right here because the B that's first is how you tell that that's the starting point of the ray, and then the arrow says it goes through point A, and so that's showing you that it's coming this way. The last question kind of looks like the same thing as question C, but this one has a teeny tiny, you might want to make it bigger, little arrow right there, and it says give another name for ray CD. So normally there's only one way to name rays, but because ray CD, the ray that starts right here at C and comes down and goes through point D, because it goes through point B, technically, if I wanted to, there's only one other way to name this one differently. I could call it ray CB, because if it starts at C and goes through B, it's eventually going to go through D anyways, because rays go infinitely long in one direction. So I could name it differently like that, but that's the only different way that I could name this ray, and it's just because this point here in the middle was a little bit different. Geometry is all about being really specific about the things that you write. Okay. Always, sometimes, and never questions are hard because sometimes they require you to think about pictures that you have to be able to see in your brain. So for question number 4, it says determine whether each statement is always true, sometimes true, or never true. So the first one says TQ and QT are on the same line, or they are the same line. So if a line goes through T and Q and it goes infinitely in both directions, and then if a line goes from Q and T and goes infinitely in both directions, you can feel comfortable saying that that one is always true as long as you're talking about the same 2 points. So as long as the T and Q are the same, then that would always be true. The next one says that if you have a ray that starts at J and goes to K, but then you have a ray that starts at K and goes to J, and they want to know, are those the same ray? That one's actually a never question. It wouldn't be possible for rays to start at different places and go through the other letter and still be the same ray. That's different than this question was up here. All right. For question number C, it says 4 points are on the same plane. You can probably think about what a plane looks like in your head and think about how it would be possible to have 4 points on the same plane. But if you had 3 points like A, B, and E on the same plane, and then you had point C up here, it's also possible for them not to be on the same plane. So whenever you can think of an example when it works and an example when it doesn't work, that means that the answer is sometimes. And then this last one's a little bit tricky because of the way that it's worded. It says 2 points are on the same line. So you can look at point A and point B and see that they're on the same line. But then you might look at point E and point C and be like, well, those aren't on the same line, so I think that this is sometimes. But what's tricky is just because there's not a line drawn on the picture that goes through points E and C, you could draw a picture. You could tilt it at a slant, and you could draw a picture through points E and C, or you could draw it through points A and E, or you could draw it through points E and B. So just because there's not a line drawn on the picture doesn't mean that it's not going to necessarily be true. So one of the things that's true about lines is that 2 points can always be on the same line if you draw the right line through them. And so the answer to this one is always. Question number 5 gives you 2 written descriptions, and it asks you to draw what they look like. So the first one says points A, B, C, and D are not on the same line, and then they want you to draw in a segment, a ray, and a line. Sometimes when you do these, it's helpful to do them in pencil instead of pen because you might wind up needing to erase. So they want A, B, C, and D that are not on the same line. Well, let's see. A, B. I wonder what would happen if I drew them in a square. So let's say this is A, this is B. This might not work, guys. This is C, and this is D. I made these notes last year. All right. So they're not all on the same line, obviously. And then it wants us to draw in a segment. Notice how this doesn't have any arrows on it. So it wants us to draw in a segment from A to B. So there's my segment. And then from B to C, it wants me to draw a ray. Yeah, this is a little weird. And then from A to D, it wants us to draw in a line. So even though my picture is super random, technically this picture that I just drew in with here's my point A, here's my point B, here's my point C, and here's my point D. Technically this picture works and I followed the directions. It is possible that you could draw this picture many different ways, but the way that I drew it in satisfied the 3 things, 1, 2, 3, and not on the same line. So it satisfied the things that it wanted me to talk about in the directions to the question. Question B wants me to draw 2 rays, and it doesn't give me any letters to use, and it wants them to intersect at their initial point. So wherever it is that they start, they want them to intersect. I'm going to draw this picture over here off to the side. So let's have this be my initial point. Here's one ray, and here's the other ray. I would need another point on each of those rays to name them. So let's have this be M. I don't know, this can be N, and this can be P. So ray MN and ray MP would intersect at their initial point. Initial just means where they start. And so we took their rays, and they intersect at their initial point. Whenever you're drawing pictures in geometry, I want you to remember that there's usually more than one way that you can draw them and have them be right. It's all about making sure you have the vocab right in your head, and that's why we spent so much time on the front of the notes practicing the words. All right, on example number 6, it says plot the given points in a coordinate plane, and then they want you to decide whether the segments A, B, and C, D are congruent. You don't need the word the here. You can cross that out. So let's remember our coordinates. So A is at 2, 2. B is at 4, 2. So there's A and B. And I'm going to label them as I go so I don't mess up which one's which. And then C is at -1, -1. And D is at -1, +1. So this one's D, and this one's C. And so right here, whenever you see the 2 letters right next to each other without the segment line over it, this means that they're asking for the length of the segment. So what they're asking you to find out right here is how long is AB. So A to B is 2 units. And then from C to D, if you count it on the picture, it's also 2 units. And so you would say, yes, those 2 segments are congruent because they have equal lengths. On the next one, I'm going to plot my points as well. So I've got -3, 4. And I've got 2, 4. So there's my first one. Let's see. So this is A and this one's B. So that's 1, 2, 3, 4, 5 in length. And then I have -1, 4, which is right here. And then I have -1, +1, which is right here. So this one's C and this one's D. And so from C to D is only 3, and so you'll conclude that those ones are not congruent. If these were slanted, so if they were on a diagonal, then we would have to use the Pythagorean theorem to solve for them, but that'll come up later when we're practicing this once we get a little bit more practice. In the homework tonight, or in the assignment for today, they're going to both be either vertical or horizontal lines so that you can just count them. The last part on today's notes is just a quick little summary about radicals and what square roots mean. So a radical is defined as being an expression that uses a root such as a square root. So just a quick little reminder, a square root means whatever do you times by itself to get back the number that's on the inside. And so when it's a square root like this, 7 times 7 gives me back 49, so 7 would be my answer to the question. Sometimes the numbers come out beautifully, and we call those perfect squares. So on the ones down here, these first 3 should look familiar to you because they're numbers that you usually remember. The square root of 9 is equal to 3 because 3 times 3 gives you back 9. The square root of 16 is 4 because 4 times 4 gives you back 16. And the square root of 1 is 1 because 1 times 1 gives you back 1. The next 2 are a little bit different. There is no whole number that you times by itself to get you back 3. So 3, the square root of 3, cannot be simplified. You could get out your calculator and you could type it into your calculator and you could change it into a decimal, but that's not the point of what we're trying to do right now. The square root of 3, if you were going to approximate it, would be approximately 1.73, but that's not what we're being asked to do. We're just trying to see if we can simplify it at all. So that one cannot be simplified. 11 also cannot be simplified because it's not a perfect square. Cannot be simplified. If you type in the square root of 11 into your calculator, you get 3.32. Now that's not what they're asking us to do. I'm just adding that on there because it's good to write extra stuff down on your notes, but that one cannot be simplified. 24 and 12 are kind of trick questions, and this is the first time that some of you are seeing this, so I'm going to slow it down for a second to make sure everybody gets this last part before we finish the notes for today. 24 is not perfect, but 24 has a perfect one hiding inside of it. So you want to think about the numbers that multiply to give you 24. You can do 1 times 24, but that doesn't help you because that's the same number you started with. You can do 2 times 12, but that doesn't help you because you don't know the square root of 2 and you don't know the square root of 12. So for 24, if I broke 24 up into 2 pieces, I'm going to pick the square root of 4 times the square root of 6. And I pick 4 and 6 for a very specific reason. I don't know what the square root of 6 is. This one can't be simplified anymore. But I do know that the square root of 4 comes out as a regular 2, no more square root, because 2 times 2 gives me back 4. So if I was being asked to simplify the square root of 24, the 4 can come out as a 2, and so I would write my answer to this question as 2 square root 6. The 4 that was underneath comes out front as a regular 2, and then the 6 that's right here stays stuck on the inside. 6 is still 2 times 3, but you don't know the square root of 2, and you don't know the square root of 3, so you just leave it inside. And then I would do the same thing on this last question. 12 is 1 times 12, but that's no good. 12 is 2 times 6, but that's no good. But 12 is 4 times 3, both still underneath square roots. The 3 can't come out, but the 4 can come out, and the 4 comes out as a 2. And so when I write my simplified answer to this one, the 2 comes out, and the 3 stays in. So these answers down here are called simplified square roots. They're the answers to the question that you get when you're being asked to simplify what the square root is. The first one, when you simplify it, it turns into a 3. The second one turns into a 4. This one turns into a 1. This one can't be simplified. This one can't be simplified. So they would just stay the way they are if you're being asked to simplify them. And then these two, they can change because you can take a number outside. It just so happened that this one was a 4 and this one was a 4 that both came out as 2s. But you're going to be looking for different numbers when you practice this. So you're going to be looking for 9s that can come out as 3s, and you're going to be looking for 25s that can come out as 5s, and all the different numbers that you know are perfect squares.